Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 16E assignment. First one we're going to take a look at here is number 3. This contingency table shows the responses of a randomly chosen sample of adults regarding the person's weight and whether they have diabetes. Conduct a ChiSquared test for independence at a 5% level to determine whether there is a link between weight and suffering from diabetes. Okay, so we're going to want to go through our 7 steps of the chi-squared test for independence. So step 1 is we have to set up our HO and our H1, right? HO and our H1. And basically, again, remember HO is always that nothing has an impact on anything else, so that would be weight and diabetes. ETES are independent of each other. So therefore H1 would be weight and diabetes are dependent of each other. Okay. Step 2 is going to be write down our significance level, and it gives us a 5% level. So step 2, significance level alpha equals 0.05. Okay. Step 3 is our degrees of freedom And remember to do that, probably the easiest way is to cross out a column and a row, and the pieces that we have, the number of cells we have left is the degrees of freedom. So in this case it would be 2. So I'm going to undo that since we need that data here. So our degrees of freedom is going to equal 2. Step 4, the contingency table is we already have right here, and we're going to use that to come up with our chi-squared calculated piece here, right? So squared calc is going to equal, and that's where we're going to use our calculator to figure this all out. Okay, now we can go through it because we need our our observed and our expected tables. We can do the expected table by hand, but also actually the graphing calculator will calculate it for us. Okay, so just to show you how to do each cell by hand, just in case if it happens to show up on the IB test, what you want to do is we want to add up the totals in each column and in each row. So 79, 89, this is a total of 90, 68, 78, what's that, 87, 69, 79, 89, 95. Okay, and then when we add these all up, that's what, 30, 40, 56. And then I'm going to do that on the calculator because that's a little big for my brain. 79 plus 68 plus 69, and that gives us 216. Okay, and then just to double check to make sure you got these numbers right, you want to add these two should add up to these 3 here. Okay, so if we take 216 plus 56, that gives us a total of 272, which will be useful here in a bit. And then let's double check. 90 plus 87 plus 95 gives us 272 as well. So we know we've got all of our columns all figured out here. Okay, so let's say if I wanted to figure out the diabetic and light, so this cell right here for our expected. Okay, so what we got to do for that is we take, to find this expected value, we take the row total by the column total. So we would do 56 times 90, and we divide it by the total, which is 272. And when we do that, 56 times 90 equals, divide by 272. We end up getting that this cell's expected value should be 18.53. Okay, and you can do that for all 6 of those if you want, but again, our graphing calculator will actually calculate these for us. So here's how we do that. Whenever we're doing the ChiSquared test for independence, instead of the goodness of fit test, we want to actually, instead of using our stats, we're going to actually go into the matrix. So we're going to clear that out. Second matrix, and we want to go over to edit. Okay, so we're going to edit this, and it's going to ask us what size matrix. So it's rows by column. So it's 2 rows by 3 columns. So we do 2 times 3. And the good news is when you enter that in and you push equals, if it doesn't match this exactly, you just know to go back and fix these, because some people will get the rows and the columns switched around. Anyways, we have this correct, and then we will simply enter in all this data, and I've already done it ahead of time. And again, instead of going through and hand calculating all of these cells, the graphing calculator will actually tell us what each one of those cells is supposed to be. So just to show you how that works, we will, because this is actually going to help us figure out the chi-squared calculated anyway, we're going to go back into matrix. So we do second, actually let's do this, let's do second quit, get out of there, oops, there we go. And now we want to do second matrix, and we are going to go, oh actually we already have it in the matrix, sorry. So we want to go to stat, go over to tests, and we go down to chi-squared, and it's the chi-squared test instead of the goodness of fit test. So we push enter, and observed, this here means table A, and the expected is going to show up in table B. Now your table B can be whatever you want, because it's going to change the table B to all the expected values. Okay, so we go down through all that, and we're going to do calculate, and it's going to give us our chi-squared value, 6.61, right? And it also gives us the p-value, which I don't think we're going to actually end up using. It does actually ask you in step 5 to come up with the p-value. That's right. So p-value is, in this case, 0.037. Okay. And now here's the part. If they're going to ask you for the expected value table, what we can do now is go back into matrix, second matrix, and then go over to edit. And if we go down to number 2 and push enter, it will actually have all of our data in there, and it's telling us that the top left data value should be 18.529, and guess what? Oops, we didn't write it down from when we hand calculated, but that's what we had. 18.529 is supposed to be that spot there. This is the observed table, but the expected values table would be 18.529. If you'll remember that from, let's see, oops, yeah, there it is. There's our calculation that we did when we did 56 times 90 and divided it by 272. We got our 18.529, which is exactly what our graphing calculator tells us. Okay, now again, on this, it's not asking you to come up with the expected value table, but IB test, if they have chi-squared on there, they're almost certainly going to ask you to at least figure out 1 or 2 of the cells in there. So that's how you do it by hand, and then that's how you can check it on the graphing calculator. Okay, sorry, back to what we're doing. P-value we figured out. Step 6 is we're going to want to do our rejection inequalities. Okay, so our step 6 here says reject. It's our rejection inequality always. Reject HO if, and then now they give us 2 opportunities here. We can reject HO if the p-value is, I'm going to p-value is less than or equal to A, or if our, and I'm going to write this backwards from what they have in the textbook, chi-squared critical value is less than or equal to the chi-squared calculated. Okay, so either or. We're going to set these both up just so that we can feel good about our understanding on this, I'm hoping. So our p-value is 0.037, and our value here we get is our 5% level here, so 0.05. So that's 1. And then our chi-squared critical value, I don't need that much space there. Chi-squared critical value, we haven't actually calculated yet, but we'll need our table for that, and we'll pop that up here in a second. But we do know that the chi-squared calculated is 6.61. Okay, so here's our critical values table, right? So we're going to do a 5% level, which is this right here, and our degrees of freedom. Take out a row and a column, and our degrees of freedom was 2. So we get 5.99 is our critical value, 5.99. So 0.037 is indeed less than 0.05, so that's true. And over here, 5.99 is also less than or equal to 6.61, so that is also true. Okay, so in both facts here, we're going to reject HO, so therefore reject HO and accept H1, that weight and diabetes are dependent of each other. Okay, so that's step 7, determine if they are, and yes, we're going to accept H1. Okay. One quick little fact that I forgot to share with you way back here when we did, we went into matrix. Actually, wait, it wasn't. I keep doing that. When we did our chi-squared test, come on, there it is. It's just my calculator's slow. There we go. All right. When we did our chi-squared test here and went down here to calculate, notice also it actually tells you what the degrees of freedom is. So if you're like, I can't remember exactly, it's going to actually tell you. But hopefully degrees of freedom is pretty easy to remember. Cross out a row, cross out a column, find the number of cells, because officially it's rows minus 1 times columns minus 1. Anyway, okay, moving on to the next one, which is number 5. Guests staying at a hotel are asked to provide their reason for traveling and to rate the hotel on a scale from poor to excellent. Results are shown in the table. Okay, show that at a 5% significance level, the variables reason for traveling and rating are dependent. Okay, so we're going to want to do our test here. So step 1 is setting up our null hypothesis and our alternate hypothesis, right? So null hypothesis, the reason for traveling and the rating are independent, right? Because it's business versus holiday. So reason for traveling and rating are independent. RA rating are independent. Right, so therefore the alternate hypothesis is going to be reason for traveling and rating are dependent. Okay, so that's our first step. Second step is the significance level, and it says right here 5% significance level. So significance level alpha equals 0.05. Third step here is degrees of freedom, right? So remember, we cross out a row, cross out a column, count the number of cells left over, which in this case is 3. I'm going undo that because we need that data here. So degrees of freedom, otherwise known as DF, that's a D, equals 3. Okay. And then step 4 is when we're going to figure out what chi-squared calculated is. Chi-squared calculated. And then 5 is also going to be our p-value. I'm just going to write those both down now because we're going to find both of those when we calculate. Okay, so let's move this over here so we can see everything. And we're going to go into, remember when we're doing chi-squared test of independence, we want to go into matrix instead of data. So we go into the matrix, we go over to edit. This one here has got 2 rows by 4 columns, so we'll do 2 enter 4 enter, and it shows up all our correct data. And now we're just going to enter in our data here. So here's all of our data. Once we have the data in, we'll go over to stats, go over to test, and we will go down to our chi-squared test. Okay, push enter. The observed is in matrix A. The expected will show up in B. It will calculate it for us, so we don't have to have that. In fact, that's not even one of our steps, is to show the expected table, but it's there if you want it. Go to calculate, and it gives us chi-squared is 23.62, we'll call it. And our p-value is 2.99. Back up. P-value is 2.99 e to the negative 5th. So what we want to do with that is 2.99 e to the negative 5th. Oops, I got to move this over so we have room. 2.99. Negative 5th means we moved over the 1, 2, 3, 4, 5 spots. 0.1, 2, 3, 4 zeros. 0.1, 2, 3, 4, 2, 9, 9 is our p-value. So it's really, really close to 0. Okay. So let's see if there's any other important stuff. Degrees of freedom, which we already figured out was 3. They verify that it is 3. Okay. And now it's off to rejection inequality time. So reject HO if, and that's when our p-value is less than our alpha, which is our significance level, or if the chi-squared, let's see, it's our critical, right? Critical is less than or equal to our chi-squared calculated. So let's set all of those up because we can. The p-value is 0.0000299. Is that less than our alpha, which is 0.05? This is true. So this is saying reject HO. Reject HO. Therefore, accept. Oops, I'm running out of room because I need this space here for that. So accept H1, which is that they're dependent, and it shows right here, show that it is dependent. So we've shown that with the p-value, and we can also show it with the chi-squared. So the chi-squared critical value we have not come up with yet, but we do have the chi-squared calculated, which is 23.62. Here's our critical values table. Our degrees of freedom is 3, and our significance level is 5, so that intersects at 7.81. 7.81. Is 7.81 less than 23.62? True. So we are going to reject HO. and accept H1, the alternate hypothesis. So if you'll notice, both tests work to accept H1, meaning that the variables reason for traveling and rating are dependent. Okay? Okay, so dependent, and then also just so that we kind of get an idea, look, excellent for business is pretty low, but for holiday it's pretty high. So people on holiday are much more likely to let's see, give the hotel an excellent rating if they're on holiday versus business. Okay? Okay, that's all we have for 16E. If you have any further questions, please feel free to ask in class. Thanks.